name is Anastasios Economides, and my co-authors are Zacharoula, Papamitsiou, and Eirini Karapistoli. We are from the University of Macedonia at Thessaloniki, Greece, and I will present an ongoing research that we are doing on temporal learning analytics. This talk will be on applying classification techniques on temporal trace data for shaping student behavior models. So we will use temporal data in order to profile students and in order to use this later. So we are the Computer Networks and Telematics Application Lab, our website, and some pictures from the University of Macedonia in Thessaloniki. So the presentation will cover the problem statement, profiling learners using actual real data. So the keynote speaker in the morning talked about real data from measurements. So we do this in order to improve the personalization of the educational services at a scale, so massive educational services. So we will use response times of the students for modeling the user behavior, and we will present previous research on this area and motivation for this study. Then we will present the case study that we have done, the experiments. We applied supervised machine learning classification techniques in order to classify the students according to the measurements that we have collected. Then we will present the results, contribution, and future research. So the problem statement. There are differences in the learning behavior, and this affects their performance. This is well known in education. So we need to detect and identify these differences and in order to build learning models, learning profiles. So the student is described by his knowledge level, his cognitive knowledge level, his affective states also, his emotions, and the metacognitive skills that he has. Learn to learn, self-regulation, and motivation, and other things also. So we have static characteristics for a student that don't change during time. That is age, gender, etc. And dynamic characteristics like personality, learning strategies that he follows, preferences, critical thinking, communication, collaboration, emotions, etc. These things can change over the time, either in a small scale or large scale. Previous studies. Barua and al., they have used temporal data in order to model long-term goal-setting representation of the students. Belk and al., they use response times in order to describe and discriminate verbal and imagers learners. Bixler and De Mello, they use time spending in order to classify the users. And Sich, Koendiger, and Science, they use response times to model the students' time and spent and capture behaviors with respect to reasoning and self-explanation. So the temporal interpretation of the students' behavior will lead us in order to explain satisfactorily their actions, what they are doing, why they are doing, to explain their performance, and to predict their progress. Also, in order to track and monitor the time-based behavior of the students, this is cost-effective. We don't need a lot of resources for this task. We consume low computational resources and can easily be implemented in computer-based assessment systems. We want to model the dynamic student behavior based on the analysis of seamlessly So we don't interfere with the student, what he's doing. We just monitor him or her. And we trace his or her response times. So the goal is to unobtrusively classify students according to their time spent behavior during assessments. So the first question is, can we classify the students according to the time spent behavior during the assessment? And when we say time spent behavior, how much time the student stays on every question, how many times he comes back on the same question, what is the time that he spends in order to answer correctly the questions or wrongly the questions, or these are different measures that we measure during the exam. And also, next, we use supervised machine learning classification methods in order to find what classification algorithm is best in order to have the most accurate results. So what is the problem of supervised classification? Suppose that we have a set of data that contain observations and measurements from different variables, and we know the classes. And if the predictor values are obtained from new observations, can we determine in which class these observations belong? So the task is to assign the objects, the students in the problem here, to one of the several predefined classes. So we need a function to map each input-output to a set of classes. Now the experiment. We have 259 participant undergraduate university students, 108 males, 151 females, at ages 20 to 27 years old. We used 12 groups of 20 or 25 students because the lab was, we didn't have a lab for 259 students. So we had one lab, and we entered, the students were entering the lab periodically. And they take exams for 60 minutes. We have 34 test items in order to test the students on issues like databases, information systems, introduction to e-commerce. So this was the subject of the class, and 34 questions, multiple choice questions on these topics. This is the layers system that we have used. We have developed it by ourselves. This is one question about databases, and it is multiple choice questions, so the student has to choose one of the 4 answers. And here it shows how many questions have been covered by the student, and what is the score for each question if that question will be answered correctly. The student does not show if he answers correctly or wrongly when he takes the tests. So what features we can have that describe the student? The student ID, the task the student works on, the answer the student submits on every question, the correctness of the submitted question, answer, the timestamp the student starts viewing a task, a question, the timestamp the student chooses to leave the task, save an answer, and leave the task. We talk about task because this can be applied to any kind of assessments, not only to multiple choice questions. The total time the student views the tasks and submits the correct answer, the total time the student views the tasks and submits the wrong answers, the idle time the student spends viewing each task, how many times the student views each task, how many times the student changes the answer they submit, the student's total time on task, the student's goal expectancy. These are different measures that are perceived measures. So we ask the students if you are satisfied with your homework and what you have done in order to take this exam, and what do you expect to achieve in this exam. So what is your goal for this exam? The effort required. Okay, again, today's keynote speaker talked about the effort. We have done some previous studies to define the effort using actual data also. And the student's actual performance, what he has achieved during the exam, the assessment. So the number of attributes that we select in order to fit the models and eventually make the classification of the students is very important. Some of the attributes were noisy, so there were not sufficient for the task that we want to do. So we have to reduce the dimensionality of the data. So we ranked the 15 attributes from the most to least informative, and we choose 5 of them. We'll show this in the next slide. We choose these features: the total time to answer correctly the answers for each student, the total time to answer wrongly, the total idle time, the effort of the student, his or her actual performance, and his or her goal expectancy. And I explained what is the goal expectancy previously. We used these 5 methods in order to compare which one of them is better in order to classify the students. We use artificial neural networks, support vector machines, naive Bayes, k-nearest neighbors, and backing bootstrap aggregation in order to see what method is best. The criteria in order to compare these methods, these algorithms, is the resubstitution error, true test error, the proportion of misclassified observation on the training set, so what is the ratio of misclassification, the cross-validation. We use the k equal to 10-fold cross-validation with 100 iteration. We've done also sensitivity analysis that ranks the variables in terms of the importance, as I told you before about the importance of the features according to the sensitivity measure. And finally, the F-score or F measure that measures the test's accuracy. And we have these results for these algorithms. So these are the classification methods, and these are the criteria for each method. This, for example, the true test error. We see similar results for all the methods. However, we see that ENS has some better results. For example, the sub error is 0. Okay, this, and again with 4 and 5 features. Okay. Using 4 features, we have these results for ANS, and 5 features, we have these results, so similar results. So the findings: all methods achieve high classification performance. so they are doing well. The true test error varies from 0.24 to 0.28. With 3 features, the total time to answer correctly, total time to answer wrongly, goal expectancy, the ENS method provides better classification results, while the KNN and NB method also achieve satisfactory results. Also, when more features are explored, ENS does not seem to be affected by the additional features. So even with few features, we have good predictions. And when the number of predictors increases, the performance of KNN and NB is slightly reduced. So maybe this is strange, but this happens. Of course, it depends on what kind of predictors we use in general case. The low misclassification rates indicate the accuracy of the method. So these features, the total time to answer correctly, the total time to answer wrongly, and the goal expectancy could be satisfactorily be used to classify the students according to their computer-based testing behavior. So these 3 measures are very valuable. Most algorithms that we have used when we compare them perform worse when 2 additional features are included. But again, this may depend on the extra features that we have selected to use. Maybe this is not the case for any kind of features. So we still have to explore why this is happening and whether these additional features are appropriate for the classification purposes. So one can identify a set of functional, temporal, or behavioral factors parameters that could constitute the core components of the system architecture. And we said these at least three variables, 3 measures, in order to model the test takers and guide also adaptation, the personalization of the services and the assessment services. The nature of the data collected, time-based parameters, total time to answer correctly, total time to answer wrongly. And the general purpose methodology that we followed make this method replicable, so someone else also can do what we have done and verify or contradict our findings. And this is important because most of the studies are specific for specific case. So we try to do a study that can be generalized and can be done, can be replicated by others or in other experiments. Future directions. We will explore more the patterns of these classes that we have classified the students in terms of the time spent, and find what are the specific characteristics of the students' behavior, time behavior, affects the classification of the students for each class. And we try to develop learning models that will act simultaneously while the students takes the test. So in real time, the student will be classified in a given class in order to drive the assessment process. Maybe we'll see what can we do with this. So we try to incorporate as much as possible the dynamics of the whole process. So in real time to do the classification and drive the whole assessment process. And maybe we have adaptive questioning sequencing different according to each student profile. So this is my presentation, and if you have any questions.
Nice keeping to time. Right on time. Question?
Maybe you said it, but the goal expectancy, you wrote that's latent, and you said something about it, it's a composite.
Yeah.
How do you measure that?
Yeah, okay. It is, yeah, this measure, it is not real measurements, but are perceptions of the students. So we ask the students if they, yeah, we ask the students. So it's perceptions, while the other measurements are real measurements. So we ask the students, have you prepared enough for the exam, for the assessment? Are you satisfied with yourself? What do you expect to achieve in the exam? Do you expect to achieve 100% the grade or 80%? So this is the goal expectancy.
And you have now found that three
Major
features are the best. Did you also check whether one feature would be enough? You can probably see that immediately, but
yeah.
or two.
Yeah, I cannot answer directly because the experiments were done by my colleagues.
Okay.
So, but we have tried several in order to conclude on this. We have tried several possibilities with respect to algorithms and also with respect to features. So, yeah.
Can you talk about the bigger picture on this? So what you mentioned at the very end, that you're thinking about doing adaptive question sequencing. So I actually have two questions. The one, so why are you studying time and assessments? Why is that you're doing rather than larger scale look at entire use of the course and across a broader?
For many years, we have done work also on adaptive assessment. We know that major tests are given in an adaptive way, like GRE, GMAT. So in this test, the next question that comes up to the students, it is complicated. It is based on IRT, but usually if a student answers correctly a question, then a more difficult question comes to him. And if he answers again correctly, a more difficult question comes, etc. Otherwise, as an easier question comes. So there's an adaptation in the tests. So there are many kinds of adaptations that we can do on assessment with respect to difficulty or with respect to other features or with respect to the personality, let's say, or other characteristics of the learner. So with respect to the times that he spends on the questions, and if he answers correctly or wrongly, we have not explored it too much yet. So this is what I'm saying, that we will explore it to see what kind of adaptations we can do. It will be with respect to what will be the next question. It will be a difficult or an easier one or something else. So.
So I've got a question. I'm going to take a little bit of aim at the last of your conclusions, the very last one about the generalizable, no, previous slide, about the generalized approach here. And so the big challenge for me in that is that you use tenfold testing and not a holdout set. And I think when building predictive models, especially in education, I used to use just tenfold testing and expect that that would make my model fairly generalizable. And I found that to be a little bit of a red herring that in my models, when you have a new cohort of students, there's so many latents that have changed that that's not really an accurate understanding of my model. And then, but you have different measures, right? And so the question is, how many of those attributes of the student actually capture the latents that don't change year to year and are more robust to that? So I guess the question is, are you planning to take this work and actually transfer it to another class and look at how generalizable the model actually is?
Yes, but this we talk to more generalizability here, not only to this just to change the class, because maybe to generalize this idea not to multiple choice questions, but also to tasks, to problem-based learning or problem-based assessment, or something else.
Right, that's kind of a hypothesis based
Yeah.
on the time-based parameters.
Yes.
So you're going to actually test that?
Well, we'll see if we have funds
okay.
to finance the
Sure.
project.
Because I think that people would be interested in knowing actually how generalizable those features are. I see every year at LAK people coming up with new interesting features, showing one study with them, but I don't see anybody building
Yeah.
the omnibus model that includes and
Yeah.
ranks and compares features across
Yeah.
all of these different spaces, and I think that that would be nice, and you guys could contribute there with these.
Thank you. And also, even for just studying, for example, how much time the student spends on each subject to study, each paragraph or each chapter or each page, and maybe after each page or chapter there are some questions to answer. If he answers the questions, or go back and give him a feedback, or so there are many things to do.
Yeah, my question is, do you happen to check the errors? Like, what are the toughest cases that can be used to classify it?
The toughest case with respect to the students who are
Like the misclassified cases.
Yeah.
Like what kind of students don't fall into the typical?
Yeah. Okay, as I told you, because the classification algorithms and all these tests were run by my colleagues, I don't know all the details that they have done. So because they have done a lot of work, it's only the results. So I don't know how, if they have examined all these specific tales, and yeah.
All right, thank you.
Okay, thank you.